allowed us to move into the final design phase. And also give you an update on some of the final design activities that were completed over the past 9 months and some of the activities that are still ongoing. Then we'll describe the information that we presented here tonight and then how you can provide input for the project. At the end of the presentation, as Harold mentioned, we'd be happy to answer any questions that you may have. Before you head out to view some of the station information, if you haven't already done so. After the public hearings held in April 2007, the department addressed all comments received on the draft EIS, and that included oral testimony given at the hearings, as well as written comments received in the months following the hearings. The department completed required coordination with some key agencies to resolve the main issues that allowed us to publish the final EIS in December of 2008. Now, the final EIS identified a bridge replacement solution, alternative BR5, as the preferred alternative. As we documented in the final EIS, the comments received on the draft EIS, there was tremendous support to select a bridge replacement alternative, and specifically support for alternative BR5. The Federal Highway Administration, FHWA, they signed a record of decision in March of last year. The record of decision is the design approval document, and it approved alternative BR5 as the selected alternative, the alternative to be progressed in final design, and it granted the department authorization to begin final design. Now, what exactly is alternative BR5? For those of you that are fairly new to the project, the alternative BR5 is an alternative that will replace the existing bridge in its entirety. And we'll do that by building the new bridge right next to the existing bridge. Now, this is a simple cross-section of the existing bridge, and it's taken at the approach. You can tell it's the approach because the supporting elements are below the roadway. On the main span, the supporting elements would be above the roadway. Now, this section is looking from Brooklyn towards Queens, and it shows how the existing bridge carries the 6 lanes of the Brooklyn-Queens Expressway, with the 3 westbound or Brooklyn-bound lanes to the left, and the 3 eastbound or Queens-bound lanes to the right. Now, the department has been committed from the very beginning of the project to maintain the 6 lanes of the BQB traffic on the expressway throughout construction, no detours, no diversion of traffic down to the local streets. Now, this is how we plan to do that. And again, here is the cross-section of the existing bridge looking from Brooklyn towards Queens. We would first build the eastbound or the Queens-bound portion of the new bridge on the eastbound side of the existing bridge. And you can see how the eastbound structure is a little bit lower than the existing bridge. In fact, the roadway of the proposed bridge, the new bridge, will be about 30 feet lower than the roadway on the existing bridge. All the traffic will remain on the existing bridge, just as it is today, while construction of the eastbound structure is completed, with no detours, no diversion of traffic down to the local street. When the eastbound structure is completed, we'll shift all 6 lanes of traffic onto that structure. No detours, no diversion of traffic. That will allow us to demolish the existing bridge, remove it completely. Once removed, we'll build the westbound or the Brooklyn-bound portion of the new bridge within the footprint of the old bridge. All traffic will be maintained on the eastbound structure, which will be wide enough to accommodate all 6 lanes until the new bridge is completed. In its final configuration, the new bridge will be built at a lower elevation and will be low enough to significantly reduce the roadway grades and the sight distances, but yet it'll still be high enough to allow any tall ships that may have to travel down the creek to safely pass under it. The new bridge will include standard lane widths and standard shoulder widths, improving the safety and the operational conditions on the bridge. The existing bridge has no shoulders. The new bridge will include auxiliary lanes in both directions. And all the auxiliary lanes are simply the ramps from Brooklyn connecting with the ramps in Queens, providing continuous lanes across the bridge. This will have a significant improvement on the emerging weaving problems that exist today. Now, the eastbound structure will physically separate the traffic that wants to stay on the BQE, head up to Queens Boulevard into the Triborough Bridge, from the traffic that wants to exit to the Long Island Expressway. That will eliminate that merging weaving problem that exists today. Of the comments received on the draft EIS, there was tremendous support to select an alternative that included a bikeway walkway. The new bridge will include a bikeway walkway. It'll be on the north side of the westbound Brooklyn Mountain structure. That's the side that's facing Manhattan. And we expect to get some pretty wonderful views of the Manhattan skyline from that bikeway walkway. Now, the graphics that you've just seen are not much different than the conceptual drawings that were included in the EIS. In the final design phase, we're going to now start to move away from these conceptual drawings and start to develop detailed engineering drawings. Critical information was obtained over the last 9 months through some initial activities that was needed, or that is needed, for the detailed bridge design. And that includes field surveys, geotechnical investigations, and some environmental inspections. If you were out at the bridge site at any time during the past 9 months, it's very likely you saw any number of people out there progressing these initial activities. One of them being the field survey. Crews completed field surveys to obtain exact elevations and distances that's needed for the design, the detailed design. This will ensure that the final design is completed with the most accurate field conditions. They also captured any changes that may have occurred within the project area since we started the job back in 2002. This is a photo of one of the field surveys that were conducted. This is at the bridge in Brooklyn near Cherry Street and Barrack Avenue. The geotechnical investigation. Crews collected subsurface information of the soils and rock that are below the ground. That's needed for the detailed design of the new bridge foundations. They included soil drilling, sampling, rock pouring at a number of locations in both Queens and Brooklyn along the new bridge alignment. This is a photo, you can see it's a little dark, of the soil drilling machine that was used to take the soil samples at one of the locations of the new bridge alignment. The environmental investigations. Crews collected samples to determine the soil and groundwater contamination quality, which does exist throughout the project area. It also completed asbestos surveys on the bridge and adjacent buildings. Now, this information is needed to develop safety procedures, safety protocols to protect the workers and adjacent community during the excavation and demolition operations that may disturb some of these materials during construction. This is a photo of the piece of equipment that was used to take some of the samples along the new bridge alignment. When the record of decision was signed last March, we initiated 2 parallel processes. The final design, which we've begun to talk about, and the right-of-way acquisition process. As I mentioned, the department is committed to maintaining the 6 lanes of traffic of the BQE on the expressway, throughout construction, no detours, no diversions of traffic down to the local streets. In order to do that, we have to build a new bridge next to the existing bridge. And as we documented in the EIS, that will require the acquisition of private properties next to the bridge in order to complete the project. Now, this is an aerial photo of the Brooklyn side of the project area. You see the BQE kind of snaking through the middle there. The white or the gray color is the footprint of the bridge.